Alright, we should be going live. Hopefully it's working. Awesome. If y'all can hear me, if you'll just type in chat and say hey or something, so that way I know A, y'all can find the chat thing, and B, I know it's working. Oh no, a bunch of people just left. I guess I'm already too boring. Hopefully y'all see my PowerPoint. Should just say welcome back. We're going to be clicking through that in a little bit. And yeah, we're just going to chill here for a second. Looks like we got about 6 people in here, which is good. We're going to get started here in a little bit. And so right now we can just chill. If y'all have any questions, you can send them to me. If y'all want to go over any of the worksheets that we had earlier. Hey, what's up, Parker? The worksheet assignment we did earlier, if there's any of that stuff that you have questions on, so we can look at that a little bit. And yeah, until then we're just going to chill for a little bit and let people get in here. You'd think this is the transition bell between advisement and 4th period. We got lots of people in here. That makes me happy. I'm going to be completely honest. I'm a little nervous. It's like the first day of teaching all over again. We are just going to hang out until 1:10, so if you're here and you're good, then yeah, you can hang out to 1:10. Obviously this is being recorded, in case that worries anyone. If you need to ask questions that you don't want to get recorded, that's fine. You can just email me or something. Same, Chelsea. I'm equally excited. Evan and Chelsea, can y'all see the message I put in chat? Can y'all scroll back to past messages in chat, or does it appear some way, or is it all just whatever you see new? Okay, awesome. So hopefully people will see the other stuff I put. There's just two messages. One just saying like, hey, we're going to start. There's a little bit of delay. Another one is just about having the calculator ready. We're going to start here in about like 2 minutes. Last chance to go get your popcorn. I know you're all going to need it for this wonderful show. All right, come on in, Caleb. Let's just talk about math and pre-calc. We can use this as a distraction from other things going on in the world. Alright, we're going to go and get started. First things first, is if you don't have a calculator, I know some of us don't, you can go to Desmos. And so I'm just going to pull it up over here. If you just go to Google and then search Desmos, go in, click in. We can go in and click and go to our scientific calculator. And from here, this will give us all our functions that we have on our normal calculator. I know it might be difficult if you only have one device, trying to like both watch the stream and go in here, but hopefully you have that thing where YouTube where it does picture-in-picture and it makes a little small box or whatever. But yeah, or you can just try to watch and absorb what you can, then when we try a problem, you can go in, try it, and then come back to the stream. Or y'all are smart, creative people. I believe in y'all. Y'all can figure it out. And yeah, we're just doing what we can right now. Go back to our PowerPoint. Alright. First thing I want to do, just to let y'all know, I'm hoping to keep this under like 20 minutes. Okay, so hopefully we're out of here by 1:30 and we can call that a nice productive day. Okay. First thing I want to come to look at is look at our law of cosines. Okay. This is something we did earlier with polar coordinates, but we built it with no normal triangles. So now we're going to look at just normal triangles with the law of cosines. Okay. Reminder, some things to watch out for with the law of cosines. What color do I want to use? Purple, of course. What these different letters are, okay? Remember all our letters, C, A, B here, are all side lengths, okay? They are all our certain side lengths. And then cosine of C, cosine of this C back here, is our angle. And if you thought my writing was bad before, wait till I get a keyboard mouse to try to write instead of the touchpad. But we're going to make it work, and y'all know if and when you find something that you can't read, you're going to let me know. Alright, so as a quick review, if we were trying to solve for this angle here, this angle right here, I'm going to call this angle C, just because that's how my equation's already set up, okay, which makes this side C. Then A and B, you remember, can go either way. So we can say that this is side A and this is side B. So we're just going to go through and start plugging things in to try to find this angle C. This is a review, hopefully. Hopefully it's things you remember. We did it more with in polar graphs. But yeah. Alright, so C, my side C is 29. So this is going to be a 29 squared equals my A, I said was 21. 21 squared plus B is 13 squared minus 2 times 21, just plugging everything in, times 13 cosine of C. There's our equation. Very second grade written, but it's there. Then from here it's just simplifying algebra. There's one trick that we're going to get to after this next step, but yeah. So I'm just going to plug everything into my calculator. So 29 squared gives me 841. (21 squared), just moving on. Hopefully this is familiar. If it's not, feel free to throw something in chat. I'm watching it. There's a little bit of delay, but I'm watching it. 13 squared is 169. And then minus 2 times 21 times 13 gives us 546. Cosine of C. Alright, this is where, if we're going to make a mistake in this is where it's going to happen. We have a tendency to want to combine all three of these numbers. Okay? But we can't do that. That is wrong. That's why it's in red. We cannot do that. Alright? We cannot combine these three sets of numbers because this 546 here is multiplied by the cosine of C. So we have to treat this 546 as a coefficient. So we have to keep it separate until we've moved everything else to the other side. Okay? So instead of doing that, what I'm going to do, go back to our, we'll do green to show what we're doing. I'm going to subtract 441 from both sides and subtract 169 from both sides. So minus 441 minus 169. And when we do that, we just plug in our calculator, 841 minus 441 minus 169. When we subtract that out, we get 231. That's going to be equal to our, we still have the negative here, negative 546. Cosine of C. I'm going to pause for a second here to see if anyone has any questions about that. If anyone, because that's a potentially confusing step why we can't combine this negative 546. It's where we most likely get messed up on this problem. And I'm going to scroll everything around and make you really confused also. Alright, hopefully we're good. If not, I'll come back. Alright, from here, we're going to keep going. We're going to keep trying to isolate this variable. We'll divide both sides by negative 546. Of course, we do that. So we get 231 divided by negative 546. And we're left with negative 0.42 307,69231, blah 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 blah. I'm not going to write all that. Equals cosine of C. Alright, so right here what I want to think about is we know our unit circle now. We didn't know it last time we had this, but we know our unit circle now. And we're going to be working in degrees just because we can, and that's how angles are normally measured in non-unit circles, non-sine cosine times. But yeah, degrees, okay. When cosine is negative, alright, you can think about your unit circle potentially. When cosine is negative, what does that mean for our angle? So if you think about it, cosine is negative, well, cosine's the x values. So cosine is negative here and here. Alright, we're obviously not going to have more than 180. So if we have a negative angle here, a negative cosine I mean, our angle is going to be something greater than 90. And, you know, you can just plug this in your calculator and you can get the right answer by doing that. But I like to do this so that way I can know what's happening. Alright, so when we plug this in, inverse cosine of negative 0.423. And when we do this, we get our answer, C equals 115. And that makes sense because that's greater than 90 degrees. If you got something weird, make sure your calculator is in degrees, not radians. Alright, once again, I'm going to pause for a short amount of time to see if anyone has any flare-up questions. Cool. Hopefully we're good. If we're not, once again, I'll come back in a second. Alright, moving on. Let us try one of these. By us, I mean you. I want you to try let's do number 2 on your own. Number 2 on your own. Notice that's a slightly different problem. We're not solving for an angle like we did for this one. We're solving for something else. We're solving for this side, BC. Okay? So see if you can do number 2 on your own. And during that time, I'll answer any quick questions. Give y'all like, let's say, 2 minutes on this. Yeah. If I was really good, I'd have a timer up right now. Is there time? Oh no. Sorry. Give y'all like 20 more seconds on this. All right, cool. So give you the answer real quick. The answer is 10. Okay, if you got that, awesome. If you didn't, we're going to go over it in a second. Before we go over it, for the people who got that, if you'll go to this bit.ly, it's just bit.ly/324 Precalc. This is just let me know who you're here, let me know how you're feeling. You can fill it out later. You can fill it out now, just like be ready to go to that. If you only have one device and you can't go to that now, I'm going to put it up later also, and so you can get to it later. Yeah, that's just to help me out with the survey, just to know where we're at. Come back to this problem. So, set up this problem. We're solving for this side over here. This is going to be side A. So I'm writing my law of cosines with A on the outside. So A squared equals B squared plus C squared. I think these are supposed to be lowercase level letters, but honestly, uppercase are easier to write. Minus 2 BC cosine of A. Okay, so that's our base equation. When we plug everything in, A squared stays as our A squared equals 15 squared plus 7 squared minus 2 times 15 times 7 times cosine of 34. And you go through and you plug all that in your calculator, and you get A squared equals 99.9. And so when you square root both sides, A equals 10. Hopefully we feel alright about that. Once again, this ideally was a review, just to remember that we had these things that we did at one point. Alright, I'm going to move on to something new. And I'm excited for this because honestly, it's easier. So, we did law cosines. Next, as hopefully you might be able to guess, is going to be law of sines. Law of sines. So, law of sines is even simpler. Okay, you just set up proportions. So what this law of sines is saying is we're going to have side A, side B, and side C all on the top. So it's going to be side A divided by sine of A. And that's going to be equal to side B divided by sine of B equals side C divided by sine of C. Okay, I'm going to prove this later afterwards if you want to stick around to see that. But if you don't want to see that, if you're good, you just need to know the proportions, great. If you have these proportions, you can also flip them if that makes it easier for you. Okay, so I'm going to label my sides real quick. C, I don't remember which one was where. I think this was B and this was A. Okay, for this one, I want to go and solve the triangle. So we want to find all three sides, which we already have, and all three angles. Okay, so that's C, this is going to be A, this is going to be B. Cool. So we already have this angle up here. We already have the 115, and we have the side length 29. Okay, so we're just going to set a proportion with our sine of C and our 29. Because I know I'm solving for another angle, I'm going to put the sine on top. It doesn't matter though. You can put C over sine of C, or you could put, like I'm going to do, sine of C over C is going to be equal to, let's solve for angle A first. Let's solve for our red angle first. And so that's going to equal sine of A over A. And then from here, it's just plugging and chugging. Okay? So we're going to have sine of C. So sine of 115 over side C is 29. That's going to equal sine of A over 13. Just making sure that my angle A is across from side of 13. Okay? When we do this, sine of 115, make sure you close your parentheses when you plug in sine of 115, divide by 29. That gives us 0.03. It's really important to keep this number in your calculator. 13 or 125, 19927, blah, 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 blah. But I'm going to keep the whole thing in my calculator. That's going to equal sine of A over 13. So multiply both sides by 13. I just did the second answer times 13. So now we get sine of A equals 0.406. Inverse sine both sides, and you get that A is going to be equal to 24 degrees. It's hopefully okay. We're going to add a little more complications to this on the day that is Thursday, but this is it right now. All right, so we know A is 24. We can do the same thing to find this third angle. We can do lost sines again, or we know they all add up to 180. So I can just do 180 equals 115 plus 24. This is a beautiful drawing. If you disagree, you're wrong. Plus angle B. And solve. You get B is 41. One thing I want y'all to do whenever you're doing these problems is to turn your brain a little bit, okay? We know that angle C is up here, right? And angle C is across from 29. That's our biggest side, right? Since it's across from our biggest side, we have to have the biggest angle here. Our next biggest side is 41. Our next biggest angle is 41, and it's across from the next biggest side of 21. Those should always make sense. That the biggest should be across the biggest, the smallest should be across the smallest, and the middle should be across the middle. All right. Moving on. Last thing we have today is just for y'all to try this on your own. Try law of sines on your own. Okay. And then I have a worksheet I'm going to post as soon as I get off the stream. So it'll be up by 2 definitely. Probably a little bit sooner if no one sticks around to ask some questions. Okay. Yeah. I would try one of these problems on your own. Let me know which one you try, what you get, if you want to check it. And I'm done. That's all I got. Feel free to ask questions. Make sure you fill out the survey link. I'm posting it in the chat as well. And yeah, if you want to stick around and ask questions about that worksheet we did last week, you can do that as well. If you want to ask questions if you want to stick around for the proof of the law sines, you can do that as well. It won't take too long. And yeah, thank you all for coming. Hopefully this was beneficial. Hopefully we feel like I know we haven't practiced it yet, but hopefully with either these 4 problems on your computer screen, or the worksheet we're going to give out that I'm not taking up for a grade, but you should do it because it's going to be helpful. You can feel good about law sines. That's all I got. Feel free to type in chat any questions you got. If not, I'll hang around here for a few minutes working on these problems, and then after that I'll go on and prove the law of sines for y'all real quick. I'm glad you found that helpful, Caleb. Hopefully this helps you with any math you have in the future. Okay, that makes sense. What grade is your brother in? Give y'all another, like, let's say a minute and a half, and then I'll go over the proof of the law of sines. And yeah. Okay, cool. So he'll be learning this stuff next year, hopefully, taking pre-calc. If I'm being honest, Algebra 2 scares me. It's been a while since I've done Algebra 2, and it is a lot of new stuff. Not new stuff, but a lot of weird stuff. So, Riley, I think that graphing the sine, cosine, tangent stuff is something that's easier to do in person, where I can see what y'all are doing. And so, honestly, this stuff is moving on to the next unit. And so, when we are able to come back and do stuff in person, we'll go over the graphing, the sine, cosine, tangent stuff. Yeah, because I feel like this is easier to get to and understand. It's more like the math you've done in the past. It's easier for me to see mistakes because it's just an answer rather than versus a graph. And so we are going to be going over that, but not online if we can help it. And so what we're actually doing next time is finding area of triangles that aren't right triangles and special cases with the law of sines. All right. Answers for these real quick. This first one was 18. The second one was 56. 58, I'm sorry, 58. This third one was 36.7. And this fourth one was a little tricky because you had to find the third angle first. So you had to find that this angle is 24 and then plug it into the law of sines. do that. I'm sorry, I actually hadn't done yet. You should get 25 over here. $736. I'm not sure if that's right, Gabe. Once I show the lost signs, if we can come back to that, if you want, Gabe. Once I show the proof. All right, proof of lost signs is going to be similar to the proof. Oh, I'll post that on the Google Classroom. The assignment I'm going to give y'all is going to be due Thursday at 1. It's 10 problems, and so if y'all do them tomorrow, or you do them right after this, it should be fine. It's 10 law, sine, law, cosines problems. All right, proof real quick. All right, so we got a triangle. We got any generic triangle. Remember with these triangles, what's special about them is there's no right angles. So A, C, nor B are right angles. And so we can't normally use our sine, cosine functions. But what we can do is we can drop our perpendicular. We can drop our height. So we drop this here, make this a right angle. We can have that this is a height. Okay? From here, we have two pairs of angles, A and B. We also have C, but we're not worried about that because it's cut in half. We have A and B, and we have our sine functions that we can do. Okay? So we can say that sine of A, it's a right triangle now, so we can say it's equal to opposite of hypotenuse. Difficult because this H is a height, not a hypotenuse. Okay, so our opposite is H over our hypotenuse would be B here. Okay, then we do the same thing with B. So we can say sine of B is H is our opposite. A is our hypotenuse. H over A. Multiply both sides. I'll multiply the top one by B, multiply the bottom one by A, and then we get B sine of A equals H, and we get A sine of B equals H. You might see where this is going. When you do this, set the H's equal to each other, you get B sine of A equals A sine of B. Sine of B, please. Thank you. And then divide both sides by AB. When you divide them both by AB, the A's cancel out here. A's cancel out. The B's cancel out here. And voila. You're left with sine of A over A is equal to sine of B over B. Because we had an arbitrary A and an arbitrary B and we don't know anything about these letters or these sides, we can also say it works for C. Or if you want to go crazy, you could draw another perpendicular here, dropping down like this, and doing the same thing with angle C and angle A. I'm gonna erase that because that blue line's really confusing. That's all I really have for y'all. Hopefully this was helpful. If you have any other questions about whether the assignment we did last week or this stuff, I'm gonna switch over and post that new assignment as soon as possible. If you didn't get any of these and you want to go over it, Caleb, I'll get you in a second. And yeah, if you did get it, make sure you fill out that survey on your way out, so that way I know that you were here and you're doing the thing. It's just the bit.ly, 3/24 is the date, and then Precalc. So that hopefully is something you can remember. And yeah, thank you all so much for coming, and I will see y'all Thursday at 1 when we go over some more fun things with Precalc and triangles. You can't see me, but my hands are in the air like I'm going woohoo, woohoo. I'm not going to get a face cam. Alright, Gabe. This might be difficult. Here, I'll write out my steps for number 8. See you Thursday, Caleb. So first thing, I found this 24 by doing 180 minus 68 and then minus the 88. Alright, when you do that, you're left with 24. Then we know with our law of sines that sine of 24 over 11, so sine of b over b, is equal to, we're looking for BC, that's this side down here. So it's going to be equal to sine of 68 over 88, no, not over 88, over x, I'm sorry, for our variable. Let's just erase that. And then when you solve for x here, you just multiply both sides by x and you divide the sine of 24 and the 11 to the other side. Great question about knowing how to use, when to use law of sines and when to use law of cosines. Okay, they will both work whenever you have the information for them. Okay, and so the simplest way to say is you can use either one, assuming you have everything. My answer with it is, sorry, let me think for a second, recollect my thoughts, not get flustered. So, in my opinion, law of sines is easier. So every time I get a problem, I'm going to look and see, can I do law of sines? Okay? And if you think about the law of sines, we have to have a side A over angle A. Alright? We have to have this ratio. We have to know this ratio. So anytime you have this ratio, no, he's not, Parker, I don't think, unless it's someone with a different name. Anytime you have this ratio, anytime you know both a side length and an angle across from it, or an angle and a side across from it, I try to use law of sines, okay, because I think it's easier. When you don't have that, that's when you have to do the law of cosines. So if we were given, just on this problem right here, if we were just given the 21, the 15, and the if we were just given 21, 15, and 13, we couldn't do law of sines because we don't know that ratio. We don't have a side length and an angle across from each other. Okay? But when you do have it, that's when you want to, yeah, so this one, if we just had the yellow highlights, we'd have to do law of cosines. Once you do law of cosines to find this 29, then you can use law of sines. So to answer your question, I would use law of sines whenever you can, and then if you have to, then use law of cosines. Does that make sense? Hopefully that makes sense. And yeah, I'm just going to chill here until y'all are all good. If it starts getting long and no one's leaving, then yeah. I'm posting the assignment now. If y'all want to try some of the problems and ask questions about them, you can absolutely do that. If you want to ask questions about the summer assignment I gave y'all. And yeah, see y'all on Thursday. Thank you, Riley. I personally think that you are the best because you're here trying your best and doing everything you can. But I appreciate that. I'm posting the assignment for Thursday right now. It's just 10 problems, law cosines, law sines, solving the triangle. And so hopefully that's doable. Alright, I just posted the assignment, and yeah, if you want me to open this so we can go over some problems, we can absolutely do that. If you're like, oh no, wait, just email me and I will reopen it. But other than that, I'm going to go ahead and close down the stream, post the VOD for everyone who wasn't here, and yeah, see y'all Thursday.